Welcome back to the channel. Hope everybody's doing well, and in today's video we're going to take a little look at this data logger from Extech Instruments. This is the DL160 dual channel true RMS voltage and current data logger. Capability of measuring either two voltages or two currents, or a voltage and a current at the same time. And it's the voltage and current aspect that I was interested in to see if it could be utilised when measuring AC impedance on generator rotors. I've always fancied one of these, but they are quite pricey. The cheapest I can find this for in the UK is around about £314, but usually it's quite a bit more than that. However, this one came up on eBay, much cheaper than that, so I decided to take the plunge and have a look at it. It's obviously second hand, but does appear to be in very good condition. In the box it comes with, this is a rigid plastic case. We've got these flexible latches at the front to hold the lid closed, small little carry handle here, this hinge that folds down out the way, and then we do have a proper hinge at the back as well, hinge pin in there, so should be a fairly robust case, I think. Let's put it back in there. We've got these two bits of paperwork with it. We've got these printed off sheets on the software. This may be because it's second hand. I don't know if you actually get this when you buy a new machine. It's probably just on the disc. I believe the software comes on a disc to you, and then you get the manual here. Let's just presume where it was originally bought from. Calibration centre there. It's a multilingual manual, but there's not much of it to it. We've got 1, 2, 3, 4 pages, 5 pages there of instrument instructions, so not a lot to this. The rest of it is in multiple languages. And then we've got the meter itself on this top layer. We've got the little meter and the two current clamps, plus this has the software on there. This is, I think it comes on CD-ROM when you buy it originally. I presume again this is because it's second hand. They've put the software onto a USB stick. Underneath here, if we take this out, put it in the lid like that, we get in the second layer, and here we have our two voltage channels just here, and then we have a USB lead to talk to the software with, and then we have an AC adapter. So the little DL160 there, it does have a battery pack inside it, but you can power it from mains. Being a data logger, that's quite a handy feature, so that comes with it, along with different adapters. That's one of those kind of power supplies. We've got 4 crocodile clips, 2 black, 2 red, and finally 4 probes. These are unfused probes. They will be a black and a red set as well. I think they are. Does it say on them? No, there's no cat rating on them that I can see. Oh no, we've got there cat 4 600 volts. Sorry, cat 3 1000 volts. Cat 4 600 volts on the probes. Same rating on the crocodile clips there. The actual voltage probes, they are cat 3 600 volts, and they will measure from 10 to 600 volts, 40 hertz to 1 kilohertz, with an accuracy of plus or minus 2% plus 1 volt, so not fantastically accurate. Our little Extech DL160 current clamps up there, they are 10 amps to 200 amps, again 40 hertz to 1 kilohertz, plus or minus 2% plus 1 amp, so similar sort of accuracy, but again, for a modern instrument that's not overly accurate, is it? As far as I know, this is just what you get with the DL160. They don't do any extra accessories that you can plug into this to change the ranges or the accuracy of the instrument. And if you see here, we've got these little DIN connectors on both the current clamps, and they are here on the voltage probes as well, so you can't add in any of your own current clamps or voltage dividers unless you can figure out the wiring for these, but then you won't be able to change the ranges on the instrument either, so you're kind of stuck with that. In terms of its sampling rate, it can sample from 1 second to 24 hours and can store up to 262,000 samples. It's the little instrument itself. Does come with a little magnets on the back, so you can hang that up, or you've got the little hanging screw there. You can also hang it up. Battery wise, we've got 4 AAA batteries in here, plus a CR2032 for the memory as well. Also worth noting that we do have little magnets on the voltage probes as well, so you can clamp them onto a metal cabinet as well when you're setting the instrument up, because the intention being to leave this for quite some time, I guess, to extract the readings that you are after. So we are set up for a voltage ramp test. You're on the SMRT, so the maximum voltage that can go to is 300 volts. As you can see, there's no voltage going at the moment, so the screen displays LO. To get to the second channel, it doesn't display both channels at the same time, which is a bit disappointment. But we go to channel 2, that's showing LO the same, so go back to channel 1. Our voltage probes do actually have designation on. Channel 1 there, and we flip over channel 2. So they are designated for each of the channels which we've plugged them into. We'll zoom into the screen a little bit so you can see a bit more. We're going to do this manually so they can flip between both the channels. So we'll switch on, and there's our 10 volts, channel 1, channel 2. 50 volts. That's 50 volts on channel 1. Where did that go, hello? There's channel 2. Channel 1. We'll go 100. 99. Channel 2. Interesting, it likes to lose the voltage every now and again, doesn't it? Let's go 175 just for something different. Let's go to the good old 230 volts, that's normal around in my country, so that'll do. Let's channel 1 drops again. It's channel 2. And finally we'll go to 300 volts, which is that one there. And channel 2, which is 300. Again, dropped again, yes. It's a bit of a strange one, that one. Not sure why it's doing that. Okay, so that's all our voltages. They all look pretty good. I will do a little table at the end of the video just to show that they are all within the manufacturer's tolerance. But that's the voltage test. I will get the current clamp table set up and we'll look at the current as well. We've switched over onto our current clamp table. You can see I can just get the 2 probes around the same coil on the clamp table together, so we can still measure both channels together. We are off at this moment in time. I'll zoom into the screen so you can see that better. Again, we've got LO because we're off. We have changed to an A for amps on the channels. That's channel 2 we're on, that's channel 1 we are on. Again, both my probes, the current clamps themselves, they are designated with a channel 1 and a channel 2, which I've set up. So we'll switch on. Should 1 amp injected, should give me 10 amp through the table, which we're on 9.5, 9.6, a little bit low on channel 1. We will go to channel 2, and we are smack on 10 amps, 10.1. So that's channel 1. If we're taking up to 50 amps, that will be 5 amp injected. So 48 again, a little bit low on channel 1. A little bit higher on channel 2. We'll go up to 100 amps, which will be 10 amps injected. Our current clamps are obviously rated to 200 amps. So it's 98.8. Channel 1. 104.5. Ooh, that could be out of spec. That'll be very close, that one. Again, I'll put these in a results table at the end of the video, and that channel button is very touchy as well. 450 amps, we are 15 amps injected. And 48.9, it's a bit better. 150, that's got to be out of spec. Now I wonder if this is why they sold it. Although we are running both clamps at the same time, so I think what I will do, let's just do our 200 amps, which will be 20 amps injected. And then we are 198, which is okay for channel 1. And then we are 210 for channel 2. Let's just take these clamps and just make sure we are trying 12. Let's no, clamp position isn't changing a little bit. 209 is the best I can get, and that's going to be very, very close to the limit, I think. So to get the instrument to record, we need to actually have this set up via the PC. This is the only way you can get it to start to record. With the software running here, the DL160 logger software, we've got a number of icons off here, your standard save, open. You can set the date and time for the instrument, and then we can actually program with this one and download results with that one. So we go to the setup here, so we can set the sampling rate, same for every 1 second. We have an auto power off of either off or on, and when the memory is full to either stop or continue overwriting the oldest data. If we hit the setup button there, and then warns you that all the data will be erased, and then we go there. Now we are ready to carry out some measurements. So that's that one there done. Shrink him down here. So to test out the data logging aspect, I have set up a current clamp. Let's just zoom out. You can see everything there, can't you? So I've set a current clamp here and a voltage input. Because of the instrument and its accuracies, I'm measuring current on channel 1 and voltage on channel 2. This is my little program here, and this will step through and actually inject voltage and amps of similar values to a generator rotor impedance test. So to get this to start, we just hold in the start button, and now we've got record come up on there, and we can click our run button here, and hopefully we should start to go up. So first one is 1.76 amps, then 7 amps, and 13 amps, and now you can see we get a measurement on the screen. And then 17 amps, and the final one should be 25 amps. So that's our little test program done. To stop it from recording, you can hit the stop button there, and then you can see we've lost record, so that's stopped recording now. And then we go back to our DL160 software, and then from our instrument we can hit the download, press download, the download button, and it starts to download, and there you can see we have our data there, and we will be able to export this data by hitting the save button. And that's all that done. Now you should have noticed that we didn't get very good readings on our current because it requires this 10 amps minimum level to actually do. So I'm going to change my setup a little bit to see if we can get that to actually work a bit better. So to overcome our initial low currents, we've used the old trick of multiple turns of wire through the current clamp itself. I've set this up with 5 turns. Our initial current is 1.76 amps, so 5 times that takes me into the 8.5-ish amps, and hopefully this meter should just start reading. It does pick up a little bit below 10 amps, although 10 amps is its specification. On the other hand, if I'd have used something like 10 turns, I'd have got the 1.76 easy enough. However, the final current reading of 25 amps, that will take me to 250 amps reading on this, which would be beyond the range of the clamp there. So really you'd end up with something like 6 or 7 turns of wire as an odd sort of ratio, but if that's what you need to get it to work. The other thing to note, we are set up now, ready to go again. If I hit the start button, once we've done one reading, you can see it won't go to record. Every single time I want to get this instrument to record, I have to reprogram it with the software. There is no choice in that. We can set this all up again, send the setup down there. So that appears to have done that. So we can press our start button again. And we've got record again. We'll inject our currents. But obviously these will be 5 times the values of the actual test current. So when I do my calculations, I would need to divide these readings by 5. Final reading there that we've got. And now we can hit our stop button. And she's stopped. And then we can go back to our software and download these results. So here's the download from our second test. We are able to zoom in. We can use the mouse to select the area to zoom in. I'm not 100% sure how well you can see. Not the best of colours on here, although you can change them. You've got our channel here. Doesn't tell you which channel it is. So that's channel 2, which is our voltage, and then we've got channel 1 here, which is our current. And again, we can hit the save button, save those, so we can get the results out into Excel, which I will put up on a different screen. So just show you these results that you get up in Excel. This comes in as a CSV file from the DL160 software. You can see we've started off with a few zeros, which is fair enough. We started the recording before we actually started injecting anything. We then get a few 10.9.99 in this section here, and 0 amps because it couldn't pick up the low reading of the amps. And then we go back to 0 volts again. And as we scroll through this a wee bit more, quite some way, we pick up another section of 10 volts. Then we go to our 40 volt setting, still 0 amps, and then 79 volts, but only one reading, and we start to pick up a current of 13.2 amps. Then we're back to a load more zeros again. And we carry on scrolling down. We then end up with continuation of the 79 volts, 80 volts setting. Then we step up to the 104, and then finally the 121 volt setting with a 25 amp reading. Sure why it's doing that. There appears to be an awful lot more zeros in there. It is doing exactly the same. This is the second data set that we picked up, and again, as we look at this, scroll through, loads of zeros, and then we get our 10 volt setting. This time this is with the 5 turns coil, so we pick up a current now, about 40 volt, then a load more zeros, and then continuing with the rest of the results. So the data all does appear to be there, but it doesn't seem to be following the flow of the current and voltages I've been injecting. It seems to be spaced out an awful lot, interjected with a lot of 0 volt readings, but each reading is marked as 1 second, which is what the data collection was set up as. We'll also just point out that all this data, the actual figures, are in as text and not as numbers. Relatively easy to sort out in Excel, but it does mean it's another operation that you've got to go to sort your data out. But that's the data from the data logging sessions that I recorded. If we pull this over into Excel properly and then print it off as PDFs. So we'll go to that there. So this is our AC readings. These injected values here on the left hand side, that is the data from what I was injecting from the previous tests on generator rotors. So that's the one we're interested in here is the Z, the impedance that comes out at the end. The first test here on DL160, and you can see we missed out 0 amps, so we can't get an impedance reading, and then we get fairly close values. They're a little bit higher, but they're reasonably within tolerance. DL160 test 2, we've now got all our readings, and this current here is the values that I've done divided by 5. So I've already processed the data through Excel, and we've got fairly close on the impedance readings there. And then our final one then. If we put this all into this graph here, and you can see our blue line here is the injected values. DL160 test 2, the second line up here, you can see it pretty much follows the same path, same profile as the other one. A bit of a mess up here, it doesn't follow the same curvature up, but it's kind of showing the detail of what we expect to see. And then finally the initial test, the DL160 initial recording, we've missed off the zeros here, but it does follow the same profile in there. So is it capable of doing it? It's a bit of a mess working it all out, but you can get there with it, and you can get some reasonable results by the looks of it. We'll just flip over now to the accuracy tests that we had. This one here, voltage wise, everything's in tolerance, both channels, no problems whatsoever. Current test wise, and this is where we had a bit of an issue. Channel 1 is all in tolerance. Channel 2, our first 2 readings are in tolerance, but our next 3 readings are not, and out by a fair old value as well, really, especially the last 2. So what I did on channel 1, I put clamp 2 on that and ran the tests, and then on channel 2 I put clamp 1 in there and ran those tests, and you see we get a flipping of the results. So it looks like the issue appears to be with the second current clamp itself, not so much with the meter. So there you have it. That's our little review of the DL160 there. It's not the best of results. It is a bit of a problematic instrument. Obviously we've got the issues with the accuracy with the second current clamp in there, but that doesn't affect me too much. I only need 1 voltage and 1 current clamp for my particular application, and I can switch it around and do channel 1 for that with the voltages we've seen. I can get some fairly respectable results. Although you can get the results into Excel, there is a fair bit of work. There seems to be a lot of erroneous data in there, and also you've got to convert it from text into numbers, which, as I've shown, you can do it. For the small amount of data that I collect with this, it's not too much of an issue. If you're using this for a much larger application and collecting a lot more data, that could then start to become a bit of a headache, unless you're really, really good at manipulating stuff with Excel. So if you can pick it up cheap and it suits your needs, then yeah, perhaps it's worth going for. But to be honest with you, I'd probably, if you're stuck with paying, recommend a retail price at £300. I think I'd give it a bit of a miss and put the money towards a power recording clamp or something like that, or even a full-blown energy analyzer, and save you money and not go down the DL160 route. But that's just my opinion, and that'll be it for this video. Thanks for watching. Hope you found it useful, and I'll see you again in the next one.